are live for some reason, mostly because Caleb insisted we have content more often. So, and since we're not editing anyways, I am Dr. Tim, but anarcho-Catholic. Oh
I
my
am
God, why can
Bulge.
I can hear myself. That's obnoxious.
Well, you're not echoing on my end, if that is any
All right,
consolation to you.
I was being dumb. I fixed it. Okay,
Okay, good.
this is Bulgakov. How you doing,
Great
Bulge?
start. I'm good. I'm great. Uh, you will notice if anyone has been trying, if anyone has been noticed, I am a little inactive on Twitter because Elon nuked me. But I will not get into this. I have already gone on a rant on Discord, so
It
we
was
will
an act of
focus.
mercy.
We will focus on. Yeah, it indeed it was. Indeed it was. Elon was saving me from myself and my addiction to X, which sounds awful. Sounds worse than a Twitter addiction. So we will focus on better things, such as trying to get through Marathon.
Right. So last time, this is probably by like a factor of 5 or 10, the fastest our turnaround for a new episode for this is going to be.
And
So I
there
think it
were
was
delays, even even in
yes.
this
We were
fastest
we were gonna
turnaround.
do it earlier, except you fell asleep. I got
Yes.
sick. It was yeah. So we're actually we might be getting better at this. We might finish the book before uh 2024. No, probably not. We
No,
might
no.
finish it in the next like within
We
12 months
might
from now.
we might finish it before 2025, which I think is the goal.
I think that is extremely likely. I'd be shocked if we were still doing this in 2025.
Well, you never know what might happen.
That's a good point. So last time we started chapter 4 of Jacques Maritain's The Degrees of Knowledge. This is knowledge of sensible nature. We went about an hour and a half or so, got through a little over half the chapter, decided we didn't want to be on for 3 hours, got to something that required a little bit more study by both of us.
Hmm.
And so we said we'd take a break and come back to it, especially since we wouldn't have to read a lot more. So here we are 2 weeks later. We're going to finish up chapter 4. Bulge, you want to sort of catch us up on where we left off and what had us sort of flummox that caused us to call it early?
All right. So, uh, we are on a discussion of what is real space. Real is in big quotation marks. I believe Mariton does actually use quotation marks through the entirety of a text. Yeah, there is no word clearer than the word reality in quotes, which almost sounds like a sarcastic comment when you put it in quotes. And as you can imagine, a discussion of what is real space quickly devolves into questions of abstract mathematics, physics, and philosophy, which, as you, dear viewer, will find out, are the main three perspectives he considers in this part. And it gets complicated because he has to consider each of them and then also define what is real for each of them and then compare which one is more privileged, or if anyone is more privileged, or what their perspectives are actually addressing, because the physicist might make an ontology out of his perspective and so might the mathematician, and that gets complicated. So we decided, especially because I don't know about Ein, but I certainly have no background in mathematics except what is needed for economics. So basic calculus and probability and statistics. So we decided to leave it off for a bit and study, and that's what we've done. And I hope that the results speak for themselves as the discussion progresses.
I'm confident I will understand it better than I would have 2 weeks ago. I don't know if we'll be able to convey that. A little bit more background. So in this chapter, one of the things that Maritain goes into very deeply is what he calls the new physics. As he's writing in the first half
Hmm.
of the 20th century, we have the discovery of Einstein's relativity theory, and at the same time the rise of various quantum theories, which um, kind of upturn a lot of the understanding of the physical world with some very new ideas and some very strange ontologies associated with them. So he's trying to a little bit at this point discuss those a little bit and understand them the way a philosopher properly should understand what these physical theories mean. And this leads him to his digression on real space,
Hmm.
because in Einstein's general theory of relativity, there's this idea that space-time, whatever the hell that means, is curved.
He
Is
gets
that
into
there's
space time, which I think you'll have a lot more comments than I do. Certainly, I just said, interesting, and, and then moved on.
but and I think he'll get into this discussion a little bit more later because you sort of have you have the physicists coming up with these ideas, and they sort of build a what will be a philosophy of nature out of these ideas, and they sort of do things a little bit backwards. You end up with some very strange ideas about how the world works that are very prevalent today. So he's really at this point, 70, 80, 90 years ago, really trying to understand concretely, okay, what is the physics actually telling us, and what is real space? How does it make sense to talk about real space being curved?
Hmm.
um, and as you mentioned, he's going to address this from mathematical, physical, and philosophical perspectives.
Yes, it's also it's not that important to know, but it might be interesting for the viewer. The book was published in 1938, so before the Second World War really kicked off, and before the atomic bombings in Japan. So that's just some background for why you will not find if he was writing in 1948, for example, 10 years later, you will probably find some comment on that and the speculation about that than generated in the general public, I think.
And I think we mentioned it last time, but as an aside, he's writing in the 1930s. Um, I'm trying to. I need to get a date for general theory of relativity, but it is new at that
19
point.
Yes, it's either late 1910s if I remember correctly or early 1920s, correct?
So special relativity was. Let's see. Hold on. Okay, so originally 1915 for general relativity, so
All
earlier than
right.
I thought. But quantum theory, and I think he makes some references to, Einstein is still a known public speaker at this point. Um, People like Schrodinger and Heisenberg are doing the work to develop quantum theory.
Mhm.
So this is very much they're very much it's very much contemporaneous to him writing this. So he is for someone that is doing theology and metaphysics and philosophy, he is very much aware and conversant in what is the cutting edge of scientific theory. So I'm always very impressed by the breadth of his knowledge. And again, if a Thomist working now would have to really dive in deep to have the knowledge of these fields that Maritain did when they were cutting edge. So
Mhm.
that always just sort of amazes me.
Yes, very much so. He does in fact name drop a few people like we would mention someone like Stephen Hawking, like Niels Bohr. He sort of mentions, it's very funny seeing these things from the past where he talks about
Mhm.
Niels Bohr like a few years ago, now I guess since Hawking did die, but we would mention Stephen Hawking as just, this guy who
Right.
who is somewhat important to his field, I guess, since I'm a layman in this area. But he name drops it as a just sort of like, he said this or he thought
Yeah,
this or
I
whatever.
attended one of his symposia in Bern or
Yeah.
whatever it was. Yeah, yeah, yeah.
All right, shall we begin or any
Yes,
more
please.
preliminary comments? All
I
right.
think that's good. Dive into it.
So I'm going to go by my notes for especially for this discussion, which I desperately needed. We begin this digression on real space with there is no word clearer than the word reality. It signifies that which is. However, there are many different ways that people interpret this word. The word real has not the same meaning for the philosopher, for the mathematician, and for the physicist. If we are aware from the outset of this diversity, the question here posed is nothing more than a nest of equivocations. The question being posed, of course, is what is real space? And just this is just my note. He's going to call the mathematician the geometrician for most of this text. So if I switch words and you feel confused, please don't. Just substitute the word mathematician. So now he starts talking about the three different meanings. For the geometrician, a space is real when it is capable of mathematical existence. That is to say, when it implies no internal contradiction and duly corresponds to the mathematical notions of space. That is, duly constitutes a system of objects of thought verifying the axioms of a geometry. Any comments before I move on for the physicist's definition?
I think that'll not for right now, because what we'll see is the two end up getting a little intertwined very easily.
Yes, especially the new physics. He has some comments on that. For the physicist, a space is real when the geometry to which it corresponds permits the construction of a physico-mathematical universe in which all of our pointer readings are explained, and which at the same time symbolizes physical phenomena in a coherent and complete fashion. The physicist is only concerned with interpreting the measurements he gathers from nature into a synthesis in which geometry and physics are amalgamated as much as possible. So the real space for physics has changed in the past and might change further in the future. Shall I get into the definition for the philosopher? I have quite many few notes in it, so it would take
So
a little while.
I'm tempted to go off on a tangent about Russell and Whitehead and axiomatic mathematics. Suffice
I'll
to say,
try
so
to
that
rein you in if you go too far. So go
please.
ahead.
So there was a movement. God, when was Principia Mathematica? You could.
1920s, I believe. I can check for you while you talk.
I'm on it. 19 Polish in 1910 again. Okay, so this is what.
Oh,
So this is
earlier than I thought.
yeah. So this was Alfred Whitehead and mathematician slash philosopher Bertrand Russell, and sort of the goal of their work. This is Principia Mathematica, and a big goal of the early 20th century of mathematics was to try and prove all of mathematics self-consistently. As they start with the bare minimum set of axioms, and then sort of discover arithmetic, geometry, algebra, all of number theory, without having to make any reference to the outside world. So you set your very very simple axioms of whatever their primitive set was, set theory or whatever it is, and then try and build everything out of that. And this is very much in line with Maritain's definition of real for a mathematician or a geometrician. If you can make it self-consistent, if you can have a self-consistent, self-contained system that contains no contradictions, that's real for a mathematician. Um, I'm trying to think who it was. Gödel came along probably
Yes.
10,
Do you?
15 years later, and
Hmm.
famously proved that the project of Whitehead and Russell was doomed to failure, because you can't any system that's as complicated, I think, is like basic algebra, can't be proved to be self-consistently true. There will always be statements that cannot be proven true or false within the system.
Hmm.
Um, so kind of kills that aspect of mathematical theory. But physicists and physics in general takes on a lot of this axiomatic mantle. Is okay, we have our set of axioms, whether they're whatever they are, and we can, and they actually will relate them to experiment, but there's this set of rules, and we write down equations, and if the equations are self-consistent, that becomes what's real. So what's
Hmm.
real for a physicist is, okay, I write down a system of equations. That system of equations is internally self-consistent, it has no contradictions, and when I try and measure something, the measurement is the same as what would be predicted by those equations.
Yeah, the world is explained, which he puts in big quotation marks in the text, by the space constructed by the physicist. And I
Right.
highlighted that this can change, that the physicist is not very wedded to whatever this, well, maybe psychologically he is, but physics as a field is not very wedded to whether a space is real or not. It has changed in the past and might change in the future, as Maritain highlights. Now it's non-Euclidean spherical, I believe, are the ones he says were in vogue at the time. Sorry,
Mhm.
elliptical and spherical, not, which are non-Euclidean, I suppose, but
Right.
let's be a bit more specific. But it might change in the future. There's no saying it's anything that can better explain pointer readings, and pointer readings might get more complicated in the future as they got throughout history.
Yeah, and that's for the physicist, as physicist, Meriton says, that's all they really care about is,
Hmm.
does this, does the ontology that you associate with the equations, because the for the physicist, for the modern physicist, the physico-mathematical physicist, as Meriton would call him, probably, the equations are the real thing. Those
Yes.
equations you can interpret as a non-Euclidean space, and if those equations predict reality correctly, then the non-Euclidean space is as good an explanation for reality as any, because because the equations are right.
Hmm. So, any more comments, or shall I move on?
Let's move on to the real, the philosopher's real.
All right, the philosopher's reel. So, I this is 3 paragraphs here that I've quoted in my notes. So feel free to stop me at any one of them. For the philosopher, which is for us, for Maritain, the problem presents itself neither from the point of view of the physicist nor from that of the mathematician. For us, it is a question of knowing what is real space in the philosophical sense of the word. That is to say, in the sense that real entity is opposed to an entity of reason, and designates an object of thought capable of extramental existence, surely not indeed according to the mode in which it exists in thought, but according to the ensemble of objective characteristics themselves which integrate its notion or definition. That was paragraph 1. I'm going to start paragraph 2 to try and clear that up a little. We can say that a mathematical entity is real in the philosophical sense of the word when it can exist outside the mind, not doubtless under the conditions proper to mathematical abstraction, but insofar as its definition reveals in a pure state or according to its ideal perfection such or such characteristics pertaining to the accidental quantity which exist or can exist in the world of bodies. Although there is in nature no point without extension or line without thickness, nor any abstract number, yet point, line, and whole number are real beings. In order to be thus an ens real, which is just Latin for real existent, such an entity does not cease to be mathematical, though it cannot have actual and sensible existence except by losing its mathematical purity. So before I move on, I can explain that a little. Basically, a number, you will never encounter the number 1 purely. You will encounter the number 1 in things, in creatures, in objects that you encounter in your life. You will not encounter it purely. You will also encounter a line, but you will not encounter a line without thickness or a point without extension. But you will encounter points and lines in your life. That's what he means by capable of extramental existence, not under the conditions proper to mathematical abstraction, which would be devoid of all these other conditions that exist in the world, be abstracted from the world. Any comment before I go on to paragraph 3?
I'd just add on to that a little bit. I think another good example is geometric shapes. So circle is he would call circle real in the philosophical sense because a circle can exist in the real world as a property of a circular thing,
Mm-hmm.
right? If you I've had pizza recently, so it's on my brain. A
Mm-hmm.
pizza, a pizza has a property because it is a real thing. The pizza itself is real. It has properties. One of those is its shape and its extension. That shape is circular. So it is, we can recognize circle in the shape of that pizza. Is it a perfect circle? No. Is it that geometric object that is circle? No. That circle can't exist by itself in that mathematically pure perfect state
Mm-hmm.
outside of as exists in our mind. But it can exist as a property of real things. That's why we know circle exists to begin with, is we can abstract that mathematical entity from real things that are circular. We can know about numbers because we can abstract several things and say, okay, how many are there? We can make that abstraction from I have said these 7 distinct apples to the number of apples I have just being a number in its pure form.
Mm-hmm.
So
Yes.
those things, I think earlier in the chapter he calls those praeter real, is these
Yes.
mathematical things that can exist but not of themselves. They can exist out of the mind in other things.
Mm-hmm. Yeah, he will bring up the word praetorial in this paragraph, so don't you worry. Let us add that though Euclidean, Riemannian, if that's how you pronounce it, etc., geometrical entities are translatable from one system to another, and that consequently all these geometries are equally true, they cannot, however, be equally real in the philosophical sense of the word. The straight line of an elliptical plane, for example, and the figure which corresponds to it in a Euclidean model are not different expressions of the same thing. In the order of the mathematical praetorial, there is no other thing than the object of thought itself constructed according to such or such a system of axioms. So it's a purely formal object of thought. So it's not different expressions for the same thing. A different expression is a different object in the praetorial. They are intrinsically different entities belonging to intrinsically different worlds, and from one of these worlds to the other, they correspond analogically. They're not univocal, they're only analogous. To affirm the reality of one space is therefore not to affirm at the same time the reality of all the others, but their unreality. No entity of these latter figures in the former. Any comment before I move on to the ways
Sure.
of knowing real space?
So I don't remember when this proof would have been, but one of the sort of big mathematical accomplishments was showing that whether it's a Euclidean space or Riemannian space, Einstein's space time, whatever it is you can make mathematical translations between them. So you could anything you could describe in one of these spaces, you could describe in the other. So we can, um, for the application to general relativity, we could describe general relativity with a non-Euclidean geometry, and things work out really nicely, and everything sort of falls in these weird curve things like you expect. Or you could also write down the equations of general relativity and describe it completely with the Euclidean space. The equations would look different; they would have a slightly different form, but they would make all the exact same predictions. We can
Hmm.
translate from one to the other. So they all the from the physics perspective, and again, the physics and the math perspective very much get blurred by modern physics. From the physics perspective, there's this sort of this sense of which it doesn't matter which one I use. One of them is more convenient for solving equations. One of them sort of intuitively feels a little bit better and is a little bit cleaner to write down. I'll use that one, and that's the one that I will base my ontology on. But they're all equivalent in terms of they make the same predictions. So who really cares? Um, as Maritain points out, for the philosopher, for the one that actually cares about what the real world is, those things are still different. Whether or not space-time is curved and things will fall like along those contours, or there's just forces that are causing them to move the exact same way they would if it was curved, there's still a difference between what those two things are. And we
Not
can
only that, I would say that his point also extends to a mathematician, because for a mathematician, though he's not considering the ontology of things, he is considering a purely formal object, and therefore a different expression that can translate into another is not the same thing. It is only analogous. I think, which I think is actually an important
yes,
point. That mathematics is purely formal. It is abstract, and therefore one expression and one expression compared to another is a different object. Every expression is an object of itself. They can't be the same if they're different expressions,
yes.
which is an interesting point, which I hadn't thought about before.
And it's funny that the physicists will I mean, doing physics, you'd be surprised that they would lose the material, but they very much lose the material and just adopt the formal. They forget that there is a thing, and they just and they let it be formal, despite the fact that their object of study is the material.
Yes, indeed. So, do I move on or any more comments on this? Because I
Keep
did interrupt
going.
you a bit. All right.
You're good.
So, in our search for a criterion, that is a criterion for deciding which space is real, two ways, and two ways only, lie open. We may either analyze the genesis of the notions in order to see if the entity in question, without involving any internal contradiction or incompossibility in its constitutive notes, in which case it would have no mathematical existence, does not imply a condition incompossible with existence outside the mind. Thus, a logical entity, such as a predicate or copula, is certainly not intrinsically contradictory, but it would be a contradiction to suppose it existing outside the mind. So, for example, the predicate tall, there is no such thing as tallness. The predicate hairy, there is no such thing as hairiness. There is only this object, this person, this thing is hairy. Or we may consider a condition to which the philosopher knows that the reality of mathematical entities is subject. He knows that for these entities to exist outside the mind means to exist with sensible existence, and that whatever cannot be constructed in imaginative intuition, which represents freely and in a pure fashion whatever belongs to quantity, has a fortiori no possibility of being posited in sensible existence. This condition is direct constructibility in intuition. So the two conditions are no internal contradiction, basically, uh, and does not imply or and does not imply contradiction with the outside, with the extra-mental world. And the second one, the second criterion, is directly constructible in intuition, which is how we organize our sensible experiences, I suppose. Any comment on that?
Just that the it's because we can't, because he doesn't want to just rely on the physics. We have to say, okay, what can we philosophically show to be real? And following Aquinas, there's nothing in the mind that is not first in the senses. We have to be able to intuit or physically understand these things directly, not in the sense of mathematical physics, but we have to have it, be able to construct it in an intuition to consider it real, because that's our sense experience. Our intuition comes from our sense experience of the world.
All right. Now, among the systems of geometrical entities that are called Euclidean, Riemannian, etc., spaces, only tridimensional Euclidean space is directly constructible in intuition. It is only by the intermediary of this space that others can satisfy the condition posited. To represent as natural to a thinking subject another geometry than that of Euclid, it is necessary to imagine a universe which is itself a being of reason as chimerical as an animal rationale alatum, as a winged rational animal. He does by that I want to be careful because I interpreted it very weirdly as first saying that he thought that the notion of a winged rational animal was internally contradictory. No, he is only saying that a winged rational animal in our world would be a chimera. It could not just, there is no such creature, therefore you would have to mix, a man and a bird or something like that. You'd have to make a chimera, such as a harpy or a sphinx. He's not saying that it is directly, a contradiction of reality. But I think he has some other comments on that in the page itself outside of my notes. But one of them is, if I remember correctly, he gets the example, I believe Eddington makes this example that if you just want to imagine the world as spherical, just look at a doorknob which has a reflection, so a shiny doorknob which reflects images, and imagine yourself as moving through that space instead of the real one. And then if I remember correctly, Mariton sort of jokes that you can only do that because you have a real Euclidean space through which you move, and that the doorknob itself is a Euclidean object in a Euclidean space.
And this sort of gets to the crux of his point, is the way that anyone invented or understood or came up with non-Euclidean spaces was by always making reference to Euclidean spaces.
Mm-hmm.
That it, like I think last time we gave the example of the sphere world, where you're on the surface of a sphere and the geometry is all kind of messed up. The only way you can make sense of so as a reminder, it's you can imagine, like, okay, if I'm in a 2D world, a flat world, it's like a big plane. How is that different than if the whole thing was wrapped around as actually the surface of a ball? And you've noticed those would be different geometries. One would be Euclidean, the flat plane would be Euclidean, the surface of the sphere would be non-Euclidean. But the way we make sense of or understand the surface of the sphere is by being able to be in a three-dimensional world and see, okay, this is how things would move around on the surface of the ball. So I have to know Euclidean space and understand Euclidean space first, and constantly make reference to it to make sense of non-Euclidean spaces.
Mm-hmm.
He also makes reference to another point, and this is, I think, getting a little abstract, because I would argue that so again, with the tangents, people might have heard, when you get into even more modern physics, like of the last 30, 40, 50 years, and people start talking about things like string theory and trying to explain quantum gravity and all that, and they start talking about extra spatial dimensions. So instead of being in a three-dimensional spatial world, we're in a 27-dimensional spatial world, or whatever number it is. There's a bunch of different theories, a bunch of different numbers. I would argue this falls into the same sort of thing Maritain's talking about. Are those extra dimensions real? And while for the physicists they would be real, for the philosopher, no. The only way we understand what a fourth spatial dimension looks like is by understanding what our three-dimensional spatial world looks like.
Yeah, so much so that the only way to directly visualize four-dimensional space is to imagine only looking at 3 dimensions of it and then switching one dimension for the extra one every now and then.
Exactly. So, but the same logic that space is not only Euclidean; it's Euclidean and three-dimensional. There can't be other dimensions, because we only understand those. That those are not directly constructible in intuition. But related to that, sorry, again with the tangents.
It's fine. Go ahead.
Another one of the things that was shown around this time with the geometry, I mentioned the example of the surface of a sphere, right? So that's a two-dimensional space that we can understand by looking at it from a three-dimensional Euclidean space, right? Is that clear?
Yes. Mm-hmm.
Okay. So the same idea can work in higher dimensions too. So if you have a three-dimensional non-Euclidean space, you could understand that in a Euclidean space of higher dimension. I think it has to be 6 dimensions. He mentions at some point what the number is, but you can construct these higher dimensional Euclidean spaces and use that to make sense of non-Euclidean spaces. So
Mm.
even then, the non-Euclidean space we understand with reference to a still fictitious but flat Euclidean space.
Yeah, it doesn't. It actually shows that the Euclidean space itself, tridimensional. He makes a point of saying that the real Euclidean space, or the only space that satisfies all of these his two criterion, is the tridimension Euclidean space. But
Mhm.
even then, the fact that we construct additional beings of reason, what is it, ans rationales, I think,
Mhm.
for to understand higher dimension non-Euclidean spaces, is to just construct like what free other dimensions or free other beings of reason and add them on to the Euclidean space. Kind of shows that this really does satisfy the condition of intuition and an imagining of sensible existence.
Mhm.
So, let's see. Non-Euclidean geometries presuppose notions of Euclidean geometries, not indeed in their own structure and their own logical development, but as the foundation of the logical coherence of the entities they may construct and as the psychological basis of conceptualization. However, the philosopher must distinguish geometric real space from physical real space. We can designate this space precisely as filled with physical existences, that is, physical space, and actions, and composed by the properties of bodies, no longer geometric, but physical, their activity and their causality into a network of tensions or of heterogeneous qualitative intensities. It is a qualified space, and the determinations that it admits are due to that which is in space and to that which fills it. Thus, the philosopher distinguishes, and it is a classical distinction, physical space from geometrical space, and can foresee that, understood in this sense as physical space, real space is not Euclidean, neither homogeneous nor isotropic, since Euclidean space is precisely that space, purely mathematical, which the mind considers after the voiding of all physical content. This was actually a very important point, which I didn't expect when I first read it. I thought he was going to be arguing for for the reality of a tridimensional Euclidean space for all of this digression.
It's funny because he goes through a lot of work to show that space is tridimensional and Euclidean, and then reminds us that space itself is actually an abstraction. When we talk about the reality of space, what we mean when we say space, because that's a term that sort of gets um
Yeah, here we go.
it's in the zeitgeist a little bit, that you could, if I say like, oh, space is flat, space is curved, space is this, we have some idea in our head what we mean by space. But what we really mean by space is itself a being of reason. Space, it's space without anything else to it. It doesn't have any other properties except its extension and its curvature of its non-Euclidean space.
Hmm.
But this is already a being of reason. This is already an abstraction. The actual space with the giant scare quotes around it has stuff in it. Is the space of the physical world, right? Um, even if it only has minimal qualities, like, I mean, there's the space that you occupy that has the properties of being, bulge, and all the properties that you have. There is space where you aren't. There might be air molecules, there might be other things, and we sort of talk, okay, what if we took that away, what if we took that away, what if we took, and then what we're left with is this abstraction of geometric space, as Maritain calls it. But again, that's an abstraction. It's, if we could take away everything else that makes that space actually exist, make it actually be outside the mind. um, and it probably wasn't even known to physicists at this point, or it might have been just barely speculated on. What we find more and more is that physical space, no matter how much we take out of it, still has properties beyond just extension. People talk about quantum fields and the quantum foam and pair production and part all these particle physics phenomenon, and it's very well understood that, oh yeah, that the empty space does a lot of stuff. So it's not empty space; it's space that still has stuff in it. It still has properties to it. And this is the point that he's making, is how does he, I love the sort of early 20th century expression of it. um yeah, network of tensions and heterogeneous qualitative intensities, is that there's stuff in it going on. It is not void.
Yes.
Void by definition is not. So
Hmm.
it doesn't make sense to talk about a real void, because if it was actually void, it wouldn't be. um
It's only
and so
real mathematically, which he's very
exactly.
careful with.
Exactly. And mathematics, as we saw a chapter or two ago, is the first degree of abstraction. We abstract away
Yes.
everything but extension. Geometry is what's left behind when you abstract away all the things that isn't something. Like I gave the pizza example earlier. If I've got a round pizza, I abstract away everything that makes the pizza pizza except its shape. The only thing left that I haven't forgotten about is shape. That's when I get to math. That's when I get the idea of circle. But again, that circle doesn't exist in itself. It exists in the pizza. The same is true of space. Space is what's left when I abstract away all the stuff that is. And if I get rid of everything but extension, I get this idea of space. But space itself does not exist of itself.
Yes.
I'm
Now,
ranting, but I love it. Go ahead.
no, it's good. Now I may have to give some context for this next quote, which, the context is basically that he's talking about a space time, which I might just read the entire paragraph. It's quite long, but or else you won't get what he's talking about. So I'll just read it. Just interrupt me or skip ahead or explain it better if you feel the need to. So, it is important always to keep in mind that when a philosopher so speaks, and this is directly after, so you're not missing anything, so speaks from the very fact that he opposes the physical and the geometrical as two irreducible orders, so they're not reducible to each other, which is very important, he understands things in an entirely different way than the new physics. Faithful to the essential spirit of modern science, the latter tends, however far it falls short of it, to be transformed completely into geometry. Thereby, and for that very reason, it abandons the absolute discrimination between the physical and the geometrical, as well as the search for physical causes considered in themselves or in their qualitative reality. In order to advance freely in this way, Einstein's stroke of genius was to have bent geometry itself to the needs of physics, and to have conceived the space which, by its geometric properties, renders account of all the phenomena of gravitation. The continuum according to which the universe is extended becomes then a non Euclidean and four dimensional continuum in which time and space are no longer measured in an independent manner but form an indissoluble complex. The geometric properties of the space time thus conceived are themselves modified by the matter which occupies it. That is to say, by what is capable of putting the measuring instruments with which we explore it off: clocks, graduated scales, light rays, compasses, electroscopes, etc. The movement of the stars follow natural paths, which are the geodesic curves of his spacetime, curves that are accentuated in the presence of material mass, so that the planets turn as in a sort of basin, owing to the incurvature of space in the vicinity of the sun, which is a very impressive understanding for a guy who doesn't do this stuff for a living. But on to the actual quote I highlighted. Newtonian physicists reproach this synthesis raised on the foundation of a vast ensemble of measurements gathered from nature and confirmed by many verified predictions with being a put-up job. Newtonian physicists would be people who are opposed to the new physics, I suppose, which was still a thing that existed at the time, which is almost quaint. They complain that the search for physical forces, which ought to account for the phenomena of nature, is abandoned. Just as the Cartesian physicists saw in the substitution of attraction at a distance for vortex motions an avowal of impotence, they, in their turn, will see an avowal of impotence in the substitution of a geometric curve for mechanical force. They forget that it was along this line that modern physics committed itself from the beginning. It was by avowing, not explicitly indeed, since in the beginning was thought to be a philosophy of nature, but practically its impotence with regard to physical causes considered in themselves or in their essences, that it began to compose a mathematical myth of the physical world, which delivers to it an enigma in enigma the secrets of that world. The quote unquote forces of classical physics appear from this point of view as a precarious compromise between the causes, quote unquote, of philosophy and the purely emperiometric entities of an evolved science of phenomena. And it must be said that the new physics has accomplished a progress of first importance in the scientific conception of the universe by manifesting, this time in a radical and explicit fashion, the renunciation by physical mathematical knowledge of the search for physical causes taken in themselves, and the profound tendency of the latter to free itself completely from philosophy. Any comments?
I think it's pretty straightforward. So I will say you mentioned earlier mathematics is purely formal. Is there is nothing material or efficient in mathematics. And as physics adopts this same mentality, it loses a lot of causality as well. It becomes almost purely formal. So he talks about the Newtonian physicists of the day that reject the framing of general relativity, that we've lost efficient causes, and that's it's true to a large extent. If you ask why does a body move the way it does, why does a star? He mentions the motion of the stars along their geodesics. Why does a star move the way it does in general relativity? A general relativist would tell you, okay, that's the way space time curves. It follows the curvature of space time along that path.
Hmm.
Thinking that that's an explanation. It's not an explanation. It's entirely circular. You constructed that non-Euclidean geometry to describe its motion. It's a description of its motion, not the cause of its motion. You've abandoned the idea of, okay, what is it that's actually doing the causing that's moving this thing? Why does it move the way it does? And you instead said, here's the equation that describes the way it moves. That's why it moves that way. You've abandoned looking for a cause with an explanatory equation. The brilliant insight here by Maritain is that Newtonian physics had already done that for 300 years prior.
Hmm.
Is that
Yes.
is when you ask why things move in Newtonian physics, someone will tell you F equals ma, or Newton's laws, or this potential energy, the gradient of, and it's math. Like if you ask a modern physicist about a classical physics problem and ask why something happens, they'll answer with an equation. They'll tell you, and there's this disconnect. They don't realize what they're doing is they're explaining how it behaves. They're not explaining why it behaves that way. Is they think that the mathematical equational description is the same thing as explaining the cause in the philosophical um, Aristotelian sense of why the thing actually happens the way it does, why things are the way they are. And so, and physics didn't really realize that it lost that 300 years ago. It had already, but it just becomes very manifest as it becomes more and more physico-mathematical. That by the time we get to the new physics, the idea of causes is quaint and forgotten, and you'll hear modern physicists very um, seriously talk about causality as being sort of an anachronism. Causality isn't a real thing that needs to be thought about or believed in, and that's because they've unknowingly but explicitly removed it from their conception of the world, because there's no causality in equations, and they think equations are real.
Yes, very much so. Which he gets into it. He doesn't directly say this, but he gets into a bit in this next part of the new physics. But let not this liberation from philosophy be taken as a new philosophy. We can take the space of the new physics in two ways: literally, in which case we will step into metaphysical confusion, or as a being of reason, which is a geometric representation of real physical space. Now, I should probably read the entire first quote on the first part on the metaphysical confusion. In the first case, it will be said, not only in the language and from the point of view of the physicist, as was accurately described above, which would be quite legitimate, but also in a philosophical sense, that the space postulated by the new physics is real geometric space and manifests the real geometric properties of the corporeal world. Hence, the latter becomes, in the measure in which the new physics has or will achieve the explanation of the universe by the geometric properties of the space invented for this purpose, amenable in itself to a purely geometric exegesis. To distinguish physical space from geometric space will then be to distinguish one geometric space from another geometric space, which we've sort of been harping on the mathematization of physics and becoming a formal science instead of a material science. To distinguish the properties of real geometric space when there is matter in it from the properties of the same real geometric space when it is void of matter, mass or energy, quantity of movement, pressures, etc., and occupied solely by something like that immaterial, quote unquote, ether, without which we have not yet succeeded in getting along, which Maritain as a Thomist must have found this really funny. The idea that people were going to find something immaterial by experimentation. At the same time, the proper object of geometry as well as its superior level of abstraction and epistemological independence, is misunderstood. To the extent that it is not a pure empty form, it is regarded as an experimental science, quote unquote, which only gets an objective content rendering it true from physical entities and physical measurements, thanks to which the mind chooses as real space the one from among the diverse formal spaces that it pleases to imagine, which permits the greatest and most perfect geometrization of physics. Under the pretext that space is a network of distances, but which the geometrician measures ideally and deductively, one will pretend to give to geometry, as a quote unquote natural science, as object a network of distances materially and empirically measured with the aid of physical apparatuses. So that's the first part. So he's basically saying that you essentially end up confusing a geometric space with a physical space, and you don't get to the real world at all. Any comment on that before I go to the second case?
I think he's saying things that we've mentioned previously, and he's just saying them more eloquently than we can. So I'm happy to leave it at that.
All right. So, let me see the second case. In the other case, the space of the new physics, whether it be empty, quote unquote, because he thinks it's hilarious that there'd be a empty physical space, I suppose, or filled with matter, will be recognized as a physical mathematical being of reason, expressly constructed in such a way as to save all the known appearances, and which will be modified in proportion to any deviations that will be observed between the construction already established by reason and new data of experience. This being of This being of reason then appears as a geometric symbol of real space, understanding physical space in the sense given to this word by the philosopher of whom we were speaking above. It appears as the geometric or metageometric symbol, which best translates the reality of physical interactivities, the ontological investigation of the nature of which is abandoned for the sake of a better mathematical analysis. So the double irreducibility, a sort of sacred good for the intellect, of the physical, ontologically considered in its essence, to the mathematical, and of the geometric to the experimental, is safeguarded. At the same time, it is understood that the geometrization of physics can be accomplished only by means of the introduction of a physics mathematically recast into the very heart of geometry itself. It will abound all the more richly in beings of reason, and in proportion as it is asked to absorb into its symbols and to mathematize real physical being, it will leave behind the more decidedly real geometric being. Any considerations on that? He has a short comment on, I think, quantum physics, which in my notes I just wrote, there is a digression into quantum physics, which I do not care about.
And basically, it's the same
I'll,
kinds of ideas
okay.
apply
I
in
can read
quantum.
it later
It's
for the viewers.
well, but it's not super important, but it's the same general ideas that you have in quantum theory. It's not as in general relativity, the focus is on geometry and the shape of space of real space. In quantum physics, it's on where things are. It's again the same idea as that we have equations that no longer need to describe reality, or that we can use as descriptions that will match pointer readings, but that can be very much divorced from what is actually there, and we replace it instead with this mathematical construct. No longer it's now a statistical construct instead of a geometric one. But again, we're getting more and more purely mathematical in our description of reality, and moving further and further away from the ontological.
Mm-hmm. So, shall we move on to philosophy of nature, or any final thoughts on his digression into real space?
Let's go on to let's finish that digression and move on to the discussion of philosophy of nature.
So you want me to read the last part of quantum physics?
No.
Oh, okay. So
Let's just go
digression
on.
finished. All right, digression finished then. Let me change my notes to the philosophy of nature section. All right. All right. So part of it is me paraphrasing. Part of it is Maritain in all of this. So begins with mere empiriological knowledge is not enough. The mind is not content with it because it cannot penetrate into the mysteries of the world. So to quote Maritain, Those philosophical or pre-philosophical substructures without which the scientists cannot get along are a sure sign of it. It is a knowledge of being itself that is needed. I mean, a knowledge of corporeal, sensible, and mobile being, of the being immanent in those realities of nature in which the sciences of phenomena reach their terminus and find their verification. Those realities which constitute the basis of all their conceptual constructions and over which these constructions give us practical mastery. Now, the next few quotes are long, so any comments on this beginning before we go on?
Sure. So we talked previously in an earlier chapter, I think, about the philosophy of nature as he describes it. So we have still what is properly physics, the second degree of abstraction, where we're considering being as changeable being. There's the sort of modern trend of it, which is this physico-mathematical, what we would in the modern days call physics, where we're looking at equations and measurements and trying to make accurate predictions. And then there's the actual philosophy of physics. There's understanding what is. So answering those questions that were ignored earlier about, okay, what causes things to behave the way they are? What are things actually? What are they ontologically? Um, and again, these are properly speaking physics or physica, Aristotle's physica questions, not metaphysical questions, but that they're still philosophical questions. They're ontological. They are trying to probe at the being of these physical things. And the point he's making here is that um, we all put on our philosopher hats from time to time. The mind automatically points itself towards those questions. It wants to know what is,
Mm-hmm.
and
It
this is
does
what
say
gets us.
this, yeah. It says the scientists cannot get along without philosophical or pre-philosophical substructures to his thought, for
Yes,
example.
but even like just in there is this the question we always think we're answering or always want to answer is what is this thing, why is it this way? We want to answer philosophical questions, and the trouble that we get into and that the new physics gets into very deeply is it doesn't have any firm grounding in philosophy, and what it has are equations. And so it tries to build a philosophy. I think you mentioned in the previous section, it tries to build a philosophy of nature out of these equations and ends up with nonsense. um, and because we always want to do this sort of myth making. He mentions these physical myths that we come up with because we have equations, and what we want to do is actually describe the world. We actually want to have ontology.
It's not
But
even that
all,
it ends up with nonsense. It ends up with more geometry, which is funny
yes,
in and of itself.
but it ends up saying things that don't.
That aren't
Uh,
true about the world
yes,
as
yes,
the
and that
world.
in that sense they are nonsense. Is that they do not correspond to the evidence of our eyes. But
Yeah,
please
don't
go ahead.
trust your lying eyes. All right. So we must take up, however, the epistemological conditions and characteristics of the philosophy of nature. It is in intelligible being itself, however obscured by sensible matter, that knowledge of this sort resolves its concepts. It belongs to an ontological type of explanation wherein the natural movement of the speculative intellect finds full play. It does not cling to empirical conditions, but to reasons of being and to causes properly so called. It aims to discover the essence of things, proceeding, as all philosophy does, according to an analytical synthetic method. It depends on experience much more stringently than metaphysics, and must be able to carry its judgments right down to sense verification. Nevertheless, it is a deductive science, assigning reasons and intelligible necessities in proportion as it ascertains the intrinsic constitutive or the quiddity of its objects. Quiddity, you can sort of replace essence uh, in that sentence. For example, it belongs to the philosophy of nature to instruct us about the nature of the continuum and of number, of quantity, of space, of motion, of time, of corporeal substance, of transitive action, of vegetative and sensitive life, of the soul and of its operative powers, etc., etc. It is also its role to consider the ontological disposition of this universe, even as Aristotle did at the end of the Physics, its relation to the first cause, and the balance between the necessary, the contingent, and the fortuitous in the course of events. Any comment before I get to his proper definition?
So I've love what he goes into here because it goes along with something that I've been saying following Maritain for a while is that this is the proper object of physica is answering these physical questions, and that naturally leads, he says at the end, in relation to the first cause, is that a philosophical understanding of again, I say physics, I mean physica, I mean the natural
Mhm.
sciences.
Physica is just the Greek word for nature for those unaware, if
Right.
I'm correct. I hope I
Yes,
am.
well, or changeable nature in any case. So
Yes,
so
yes, true.
so strictly speaking, all like chemistry, biology, um, all the sciences are probably speaking physica, unless they involve like the human mind, in which case they start becoming metaphysical because we have an immaterial soul. But beyond that, is that physics ultimately ends up pointing us towards metaphysics. Is that by answering all these philosophy of nature questions, or digging into the ontological disposition of the universe, which is a question for physica, that leads us to the relationship to the first cause and leads us to metaphysics.
Which, of
And the,
course, it must, since the metaphysics is the underlining substrate of, the foundation of the Physica.
yes, but it's foundational in a it is properly foundational, but but in our knowledge, the physica comes first. Is the physica leads to those metaphysical questions, because that's the physica is more intuitive to us, and
Yes, we
so
notice
we're
change. I might even argue that maybe part of it is simultaneous, so that when you notice change, you notice an actualization of potential. And the moment you abstract that, no, I suppose you are correct. The moment you abstract an actualization of potential and you just consider act and potency, then you're in metaphysics. Okay, yeah,
and
I see
and
what you're saying.
and I mean temporally it might be happen simultaneously, but the you have to
But
apprehend
logically,
the
yes.
physical. Yes,
Yeah, I
yes,
understand what you're saying now. I was thinking that maybe you could do them. No, but no, there's a movement of abstraction in the intellect, I think.
right. Um, yeah, but no, I love this. And in my mind, it explains what the proper role of a science should be. And in Maritain's mind, there are two very separate things. There's the physical mathematical, it's going and doing its thing, and there's the philosophy of nature that needs to go and do its thing. And never the twain shall meet. And I would argue we need to find a way to get the physical mathematical sciences to sort of re-embrace Thomistic philosophy, and understand that they should be a philosophy of nature, that they should be actually coherently answering ontological questions.
Yes, I think he sort of makes the argument that they're separate disciplines. However, the philosopher of nature has a duty to what how does he put it? To not absorb. I got got the letter wrong.
Mhm.
Absorb all the material of physical mathematical sciences, and even the
Yep.
non-physical mathematical, like a lot of biology, would not be considered physical mathematical, I suppose.
It's
Uh,
getting there.
yeah, it's getting there, but I suppose it's not reducible to the physical mathematical, as it is right now, at least.
Right.
So the philosopher of nature almost acts as a course correction for the scientists, as the word is understood today, when they get too wacky in their theories of reality. It kind of reminds them that
Yes.
what they're talking about are models, or geometric symbols, for the physicists at least, geometric symbols of reality, not, or metageometric even, not reality itself.
And what I would say, and I think it's the same thing, but what I would say is that the physicist or the scientist needs to also be a philosopher of nature. Is you don't get to
Yeah,
just
yeah.
wear the one hat. Is you need to
Yeah, he
you
would
need
just
that.
say they're different hats.
Yes.
They should. I mean, there's many cases where one ought to wear many different hats. You
Yes.
can.
But you
If
you
you're a
you.
physicist, you should also be a father, either a spiritual father or a literal father.
Mhm.
And those are different hats. When you're hearing confession, I hope you're not, uh, trying to figure out if the latest theory is wrong or not, and paying attention to the guy who's confessing to you. Or when you're with your kids, I hope you're playing with them and not
But the
not
the
doing
point being,
something else.
but to do science correctly, to do physics correctly, you must also do philosophy of nature correctly.
Hmm. Yeah. It wouldn't be in the new physics, I suppose. Not we would have to change our the current understanding, cultural understanding, at least,
Yes, but
of
I mean, I think
what it
I think
means
that's
what it is to be a physicist.
what needs to happen. I think
All right,
honestly, I think that would help
I
physics
understand.
immensely.
Hmm.
Do
Yeah,
you
I think it would too.
do you want to
All
go
right,
ahead with the definition of philosophy of nature?
all
We're
right.
kind of
So
we're
let's
kind of
go.
getting ahead of ourselves a bit.
Defining philosophy of nature. So, quoting Mariton now, we shall have to say it is a knowledge whose object, present in all things of corporeal nature, is mobile being as such, and the ontological principles which account for its mutability. For it is essentially a philosophy of mutability. This knowledge came into existence with Aristotle when he showed that an ontology of the sensible world is possible, not precisely insofar as it is sensible, but insofar as it is the very world changing being, and that it implies in its structure intelligible invariants depending upon specifying forms. So we can actually break this down and spend, I think, the next 2 hours discussing it if we really wanted to. But any comments?
I'd rather not spend the 2 hours discussing that paragraph. Thanks.
Yeah, but no comments then. Moving on, or
Yeah, that's fine with me.
all right. So it is important to remember, as St. Thomas often said, probably Aquinas, that in general, the essence of sensible things remain hidden from us because of the matter in which it is, as it were, buried. It is only in the mathematical order that we can openly consider a world of essences. That is why mathematics is the most imperious and the most luxurious of the human sciences. In the physical world, it is possible to attain to essential and specifying definitions which are certain concerning man and things of man, his powers, habitus, etc. But below man, for the most part, the element of resistance to intelligibility introduced by matter, rendering corporeal essences opaque to our view, knowable by signs rather than by properties in the ontological sense, keeps the essences hidden from us in their specificity. From these observations, it follows that the philosophy of nature cannot reach down to the ultimate specific diversities of corporeal nature, and this implies a graver restriction on the philosophical optimism of the ancients. Any comment or?
I think, and I love the flowing prose. It could be concisely said as we do not directly observe essence.
Yes. You can really put this whole paragraph in one, maybe two sentences max. You can really just say, the essence of sensible things remain hidden from us because of the matter in which it is buried. And like another sentence to clarify and move on.
And again, I think it's a lovely point, but it's one that I think he's assuming his audience will know anyway. So I don't know why he bothers to take so long to say it. But again, to summarize, in math, we can actually have essences. I can know the essence of circle as circle because it is laid bare before me. There's no matter to get in the way. I can only know the essence of a physical thing deductively and through the properties that it presents to my senses and through my intuition. I do not directly have contact with those essences, and so I'm what it was. Yeah, there's a grave restriction on the optimism of the ancients that we can know the essence of all things.
The important exception is man, of course, because we are man, and therefore we
Yes,
are, in a sense, not only direct observers, but the essence itself, in a way, almost.
we are what we are. Yeah,
Yeah, we are what we are. It's almost A is A level of thinking. So therefore, A knows, if A is capable of knowing, A knows A almost directly.
yeah.
There's no mediation there. So moving on. When it is a question of a distinction between certain vast domains, between non living bodies and living bodies, between animals and plants, between man and irrational animals, the philosophy of nature does indeed grasp the essential differences. There, we are in a region accessible to the philosopher's view, and we can attain properly philosophical certitudes in the very order of typological discrimination. In other words, we know that there is an essential difference between plant irritability and animal sensibility. We know that the imminent action by which the living organism constructs itself, the activities of sensation and intellection, all disclose quiditative, essential, really, it means the same thing, principles which enable us to penetrate into the intimate structure of the beings we are considering. We know that a body as such is constituted by two complementary ontological principles, one purely potential and determinable, the other specifying and determining, which we call prime matter and substantial form. Nevertheless, the philosophy of nature has to be satisfied in such matters with certitudes of a very lofty universality. It must abandon all the specific diversities and peculiarities in the world of bodies, all the detail of the operations of sensible nature, to what Leibniz called symbolic or blind knowledge, and we propose to call empyreological knowledge. Indeed, this latter knowledge does descend to detail, but the essence escapes it. Very interesting few points there. Any comment, or do we need to
Just
clarify?
just briefly to sort of re-summarize is like Aristotle does in De Animas, we can um, philosophy of nature still can give us something of the essence of things. Like you said, we know man is a rational animal. We know an animal is not a plant because an animal we can define animal as being as having that essential quality of sense knowledge, and being able to know a plant is different than a dead thing because it has these reproductive and nutritive powers. So we can specify those very broadly, those essences. We can say what the essence of a plant is, what the essence of an animal is, what the essence of a man is. It is much more difficult, and we run into limitations if I try and distinguish the essence of, say, a cat from a dog, as I can talk about physical features, and I might be able to get something of their essence and talk about the distinctions. But in that the specific essences, again, because I don't have I don't have direct spiritual or immaterial knowledge of these things. I'm limited in my ability to give a full or have full knowledge of their essence.
Mm-hmm. Shall I move on?
Sure.
Now, let us note that there is perfect knowledge only when we know things not in a more or less indirect, indistinct fashion by stopping at generic determinations, but by coming right down to ultimate specific determinations. If metaphysics is a perfect knowledge, we shall return to this point later in another chapter, I think, because I don't remember him returning to this point. It is because its specifying object, being, disengaged as being by formal abstraction, is not a genus, but a transcendental, which taken as such stands at the ultimate degree of logical determination. What then is the case for the philosophy of nature? Its object is not ens in quantum ens, the object of the metaphysician, so being as being. Uh, the specifying object of the philosophy of nature is the ontological mutability and formalities in which the mind can discern a difference of being, corporeity, quantity, motion, life, animality, etc., which corporeal natures take within corporeal natures taken as such. And this suffices to assure its distinction and autonomy in regard to the experimental sciences. On the other hand, sensible or mobile being is itself complete. That is to say, it has the integrity of its determinations only in specific natures. Hence, it follows that the philosophy of nature is not a complete knowledge without the sciences of nature. Experimental science and philosophy of nature are two distinct but incomplete knowledges, subject to different controls, the one above all of the intelligible and the other above all of the observable, which complete each other as best they can. They both thereby belong to the same degree of abstraction, though from another point of view of the philosophy of nature, as we have seen, is essentially different than the science of nature. So he's essentially commenting that philosophy of nature is actually not a complete knowledge of its subject matter. It is a specific view of its subject matter, which to be completed needs the experimental sciences. It is incomplete without them. They need one another to complete themselves.
Right, which I think is similar to what we had said previously.
Mm-hmm. I would have no objection to comparing the relation of the philosophy of nature with the sciences of nature to the relation of the rational soul with the body, which is an interesting comparison, I suppose. In itself, the first is independent of the state of development of the second and of their hypotheses. It relies on philosophical facts, which are much more simple and fundamental than scientific facts. I'm now debating whether I'm going to read this entire large paragraph to get to the one thing I highlighted.
How about you just jump ahead to what you highlighted?
All right. Scientific facts all by themselves cannot furnish the least philosophical decision, but the proper light of philosophical objects and principles, like the light of the agent intellect illuminating phantasms, causes the philosophical contents with which they are pregnant to issue forth from them. Yeah, which is this is the essential thing of these two paragraphs. So this goes back to your point that the experimental scientist should also be a philosopher of nature, because it illuminates them and causes the philosophical content of his discoveries to issue forth from them. Which
Perfect.
is, any comment on that, or shall I move on to the next page?
I think you're good to go on.
All right. The hylomorphic doctrine, for example, is as true today as it was in the time of Aristotle. Its vocabulary and exemplifications have grown old, but not its substance. The 4 elements of former times are replaced by the 92 elements of Mendeleev's table. They correspond to a very different scientific notion. We have a much more rigorous knowledge of the family of elements than did the chemists of 100 years ago. And then he goes on and gives several examples of, mutations and hydrogens and so on and so forth. And then goes on to say, indeed, this ensemble of empiriological knowledge lends itself better to the ontology of Aristotle than to that of Democritus or of Descartes, and may I add, better, no doubt, than the experimental conceptions in favor among the alchemists of the Middle Ages. So now we move on to complementary elucidations, which I have a large chunk highlighted on the first page, and then this sort of peters off a little. But any comment before I move on to that?
No, I think let's jump on to your large highlight.
All right, let's say. Yes! Exclamation mark. But doesn't Mr. Eddington, in his rich imagery, tell us that a body is a quote-unquote tube of a 4-dimensional universe separated from the rest of space-time by a more or less sharp limit, unquote? Surely we are far from the universe of Aristotle. We are certainly far from the scientific ideas of Aristotle, but we are talking about his philosophy. Whether an elephant be an isolated tube of a 4-dimensional universe, or a lump of flesh and bones composed of 4 elements and 4 primary qualities, in either case there is no resemblance between the idea that science or common sense forms of this animal, an idea that can be expressed in an image or in a spatial temporal scheme, which is at least reductively imaginable, and the essentially unimaginable and purely ontological conception which philosophy reaches from the first principles of which the substance of the same animal is constituted. Prime matter and substantial form belong to another noematic universe than this lump or tube. Neither favors the hylomorphic theory more than the other. It rests on something other than these images. Whether it be a tridimensional lump or a quadridimensional tube, an elephant still has to perform that operation which both the ordinary man and the scientist call eating, although they may form very diverse images of it, and it still has to end with the phenomena that both call dying. The philosopher, knowing that the elephant in question is an individual substance, one in itself, specifically different from the plant that it assimilates by nutrition and the inorganic materials into which its corpse will decompose, is forced to seek the subject of these substantial mutations in a radical potentiality which, following Aristotle, he will call prime matter, though one could wish for a better name. Naturally, he's unable to describe what figure prime matter has, either in 3-dimensional or 4-dimensional space, because it doesn't have any figure. Now, any comment before I move on to the next page?
So I do like the idea at the beginning is we're far from the scientific ideas of Aristotle. We were talking about his philosophy,
Yes.
and I always like to say that Aristotle was quite a good physicist in terms of physics. His mechanics was garbage. His empiricism was terrible, but his philosophy of nature is, like as I mentioned the previous thing, is more correct than Democritus or Descartes or the alchemists of the Middle Ages. Is he knew better what was, even if he couldn't describe it very effectively, or if he couldn't make effective mathematical predictions of their behavior. That's all.
Yes, and I quite like his image of it, that whether an elephant is a tridimensional lump or a quadridimensional tube, it still has to eat and then it has to die.
Yep.
And it is one thing in both systems, and then it stops being one thing when it dies and becomes inorganic matter. And also prime matter, you're not gonna find prime matter because it doesn't have a figure. It's not an object in itself, a lump of prime matter.
Yeah, and in fact cannot exist of itself.
Yes, yeah, by definition, almost. It's
No,
part of the definition of prime matter, but it just can't.
Yeah, because it would have if it were something, it wouldn't be matter. It would have
Yeah,
form.
it wouldn't be prime matter. It would have a form. It's not. It wouldn't be radically. It wouldn't be radical potentiality in itself.
Right.
All right. So the question then arises as to what relation the philosophy of nature can have, not now with the facts or with entia realia, real being, more or less completed by reason, but with pure entia rationalis, rational being or beings of reason, and the well-founded myths of science. Let us complete what we were saying above. We believe that the philosophy of nature ought to take over the entire material supplied by the experimental sciences. But although it can base itself on facts established by these sciences as upon foreign material that it appropriates, it clearly cannot require from a physical mathematical being of reason the means of elucidating the nature of things in itself and ontologically. It ought to make use of such beings of reason, but in another way, namely, inasmuch as the latter is one of the elements in the image of the universe established for science, by science, I mean. For the philosophy of nature cannot do without scientific imagery. It needs the image or the symbol that the science of its day fashions for the world. Any comment before I move on to the next page, or something else you want to add that I'm
I think
skipping
what
over?
I believe what he's getting into now is again talking about this sort of idea of myth making, and that
Hmm.
the normal mode is exactly backwards as we try and just create a philosophy of nature from our physico-mathematical equational um, empirical information, and not from any kind of well-established philosophy. And so philosophy of nature can use those results certainly, but it has to do it in a philosophic mode, and we can't do things backwards and start trying to make these beings of reason, like real space that we talked about for an hour earlier,
Hmm.
into the real, what the real world and we again, he's now getting into that idea that we end up getting these crazy conceptions by doing those things backwards. The proper role of philosophy of nature is to do philosophy, and in a way proper to its mode, and to use insights from the empirical, but to not let them dominate its mode of myth making.
Yes. So, on to the next page. Meanwhile, what can the philosopher himself make of a myth? Obviously, only another myth, this time a philosophical one. There is no other way for the philosophy of nature to take up into its own order the well founded myths of physical mathematical knowledge than to become a fabricator of myths in its turn. Do we not know that the philosopher is in a certain way a lover of myths? Philosophus est aliqualiter philomythes. So I'm actually going to read the very brief footnote. This is the first and only time I will do this for this show because I found it somewhat interesting and odd, in which he says, this is what I just read is a quote in Latin from St. Thomas Aquinas, because of course it is. And in his footnote, he says, as a matter of fact, Aristotle did not say that a philosopher is in a certain way a mythophile, which is who Aquinas believed he was quoting, but that a mythophile is in a certain way a philosopher. And then he, casually puts the ancient Greek there and cites chapter and verse from the Metaphysics. So Aquinas probably didn't read ancient Greek and was working with a Latin translation, and they got that phrase the other way around, which I just found somewhat charming to find that he's correcting the very phrase he's quoting in his footnotes.
It's
Which,
like, actually, if you look at the original Greek, yeah.
yeah, actually, he just actually Saint Aquinas who he's quoting in this very passage. All right,
Maritain flexing on everyone. It's amazing.
yeah. So, to give an example of what we mean, a vast field is thus open to the creative imagination of a philosopher when, for example, he aims to interpret, in the light of an otherwise well established philosophical doctrine, like, for example, the hylomorphic doctrine, the provisional image which science fashions of the microstructure of the atom. Hardly will he have invented a sufficiently probable hypothesis, admitted, for example, that the substantial form informs the intraatomic ether as well as the central nucleus and the electrons that encircle it, then the scheme of Rutherford and Bohr, to which this interpretation is related, will already be on its way to bankruptcy. He will have to readapt it or invent another, The philosopher might also busy himself with the four-dimensional universe, or with the ether that present-day physicists try not to talk about. That's in quotes. I don't know who he's quoting at that in this moment. Although it seems they will still have difficulty in doing without it. But if he thought that this was engaging in the work of philosophical knowledge, so-called, one could only regret his courage. All right, so I have one more quote before we get into mechanism. Are we ready, or any comments? And you're muted, by the way.
I am muted. Sorry. I think it's going over things we've mentioned in passing already, so I think you're good to go on.
All right. So, it is certainly remarkable that only in the world of sensible nature do we find our knowledge shared by a philosophy and an experimental science related to each other as the soul to the body. No such duality is found in the other universes of intelligibility. Mathematics has no ontological soul. It has only an abstract body, an abstract and ideal body. Metaphysics has no empirological body. It is only spirit. So that's a nice little capping off of his section.
Yep.
Very beautifully written.
He's again, there's such dense prose, and then you'll have sentences like that. It's like, oh, that's just good. Like, it's just well written.
Very, very good.
Just a little golf clap or a hat tip. Like that's just nice.
Very nice. So, mechanism, the part of which I have no notes. So there will probably be a few pages completely skipped in this, which might be necessary for time anyway.
It'll be fine.
All right. So, mechanism. Do you have any preliminary thing you want to talk about, or should I just get right into it? Because I barely remember what he talks about in this section.
Go ahead and jump into it, and I'll be able to fill in as you go.
All right. So I'll number the points as we go so that you can find yourself if you want in your copy. Point 30. If the preceding analyses are correct, we can see that the central error of modern philosophy in the domain of the knowledge of nature has been to give the value of an ontological explanation to the type of mechanist attraction immanent in physical mathematical knowledge, and to take the latter for a philosophy of nature. It is not a philosophy of nature, it is an empirological analysis of nature, mathematical inform and control, and empirometric analysis. So we've already gone over this. We've gone over this quite a bit. I'll just add this one little phrase to him, which I thought was neat, which is in the second paragraph of this point, which is, let us say that the new scientific conceptions only manifest more daringly the intent of transmuting physics into a universalized mathematics. So I skip point 31 entirely because I have no highlights of it. And then I go into Dangerous Liaisons, which sounds like the name of a French pulp novel. I'm glad it's in this book, however. Let's see. So, in Dangerous Liaisons, point 32, paragraph 3, the second principle of thermodynamics offers still other resources to the philosophy of nature, especially in regard to the philosophy of the living organism. It is not one of the marks of the irreducible specificity of living things that, without violating this principle, but rather using it for its own advantage, they profit by the universal process of the degradation of energy variously to reconstruct order and organization to raise for a time the degree of being. I do not mean as to the quality of the energy, for life does not release a special form of energy, but as to perfection of a higher order, properly biological or psychic. Material life is a constructive fire which feeds upon decay. Any comment on that? Because I do have one which is somewhat interesting.
You go ahead first.
It's not actually a comment on this itself, but there is a small essay by Nick Land which hits upon the same idea, and I am completely 100% sure Nick Land has never read Degrees of Knowledge. The idea of Nick Land is actually a very continental way of phrasing, but he says if you feel the world is very confusing, it's because we build order out of decay, but decay is in his very weird way of putting it, the forward direction of time, and we try to reverse time. So that's one way of thinking as to why the world appears weird and confusing from a very civilized man's perspective of things. Which I thought was interesting that he had this this small idea in I guess in the Venn diagram of ideas, Nick Land and Jacques Maritain share at least this one idea, which is curious.
It is a strange overlap. It's a dangerous liaison, if you will.
It is a
Um,
dangerous liaison, if you will.
one of the bigger things he's trying to do in this section is looking at, again, so we have, going into the advent of the new physics, we have a very deterministic world. We have there's sort of an understanding that is trying to leave behind, again, because it is a formal system, it's trying to leave behind a lot of the material, but it's also trying to leave a lot behind, a lot of the immaterial, and so we're left with just form. And so we have all these issues like, okay, well, we have living things. How do we make sense of those in terms of quantum mechanics or the new physics? Or he brings up the Carnot engine, or entropy in the second law of thermodynamics. And a big effort that he's trying to make here is trying to make sense of, from the perspective of philosophy of nature, because we want to understand what things actually are. How do we understand these physico-mathematical principles in terms of what we actually see? How does life make sense in the light of the existence of entropy, or the second principle of thermodynamics? So
Yes.
that's one of the bigger pictures he's
Mhm.
trying to address here.
All right. So to cap off point 32, I just skipped to the final paragraph,
Mhm.
which is not that important, but it is neat. Finally, how could the imagination of the philosopher, or of the poet for that matter, not be enchanted by those light atoms that condense and transform themselves into heavy ones in order to radiate light and heat? By that matter whose mass has its internal energy as measure, by those stars which, by ceaselessly reducing their erstwhile enormous mass, and that will go out completely after thousands of billions of years, meanwhile pour energy into the universe. How could he not see in these things huge symbols of the very mysteries of the life of the spirit?
Again, just very very nice flowery prose.
Yes, very nice. So, point 33, which is something that we've said. I'm actually going to read this. We 100% did not need to read this little section which I highlighted, but I want the viewer to understand how much he's hammering this point home, and that we're not exaggerating by repeating it. May it never be forgotten what an error it would be to try to build a philosophy of nature, and a fortiori a metaphysics, on the theoretical conclusions of modern physics and its explanations of the world, taken as ontological foundations, as if those conclusions and explanations could be utilized as such by the philosopher, and without a previous rigid critique. This or that was the error committed by Spinoza with the physics of his day. So we're not exaggerating when we keep saying that physicists, the error of a lot of physicists is to make their theory or their geometric symbol of real physical space into a metaphysical theory.
And it goes beyond just the error of the physicist. I think it started with the physicist, but
Oh,
it
it's certainly
is
spread.
it,
It's a
it
mass error.
it's the error of our time. It's the error of our metaphysics. It's the
Yeah, it's
error
in the
of the
water, so to speak.
it's the era of the Reddit atheist. Like
Mm-hmm.
it's and if you, and I've had some of these arguments on Twitter in the past. As soon as you start pushing anyone any of these ideas, they will try and use modern physics to defend their positions, not understanding modern physics, but performing this same error. Is they have they have the poem or the myth that general relativity or quantum mechanics gives, and they use that as the basis of the philosophy of nature. As their understanding of nature comes out of those myths instead of out of a genuine grounded philosophy based in the sensible.
Oh yes.
And it is the epistemological and philosophical error of our time, is that is the is that we have made the error that Maritain has said would be so grave, is that our general understanding of the world, or for most people of the world, and I think we're all guilty of it to some extent, is that we built our philosophy of nature, and from that our metaphysics is built on this um, of this myth making that comes from modern science.
So, let me see if this, yeah, he sort of gives an example of this with the indeterminacy principle. Let me see. We pointed out above that the principle of indetermination introduces gaps in the field of scientific causality, or more exactly, in the field of those substitutes for causality which physical mathematical knowledge reaches by recasting the concept of cause. But if such can be the case, it is only to the precise extent that science abandons any ontological point of view and gives up thinking phenomena sub ration entis, or under rational existence or being. I don't know what entis is at the moment because it's not ends. To give philosophical value to this abandonment, which makes sense only in the empiriological domain, would be a grave mistake. It is impossible for human science to know determinately the behavior of a corpuscle at each instant, for it observes and measures things with the aid of material instruments and in virtue of physical activities. It can only see an electron by jogging it with light. But suppose a pure spirit who knows without material means, and so no longer by means of empiriological concepts, the behavior of this corpuscle at each instant, it would see that the principle of causality applies strictly and in its full ontological sense. The hypothesis of a pure spirit has no meaning for the physicist, but if it had no meaning for a metaphysician, there would be no metaphysics. So, any comment on the science of indeterminacy principle and how it corresponds to what he's talking about?
Yeah, so there's sort of two conflicting things that are going on here. Is with the rise of quantum mechanics, you have this idea of indeterminacy. You have Heisenberg's uncertainty relationship, which again, the myth making goes that you can't describe the position and momentum of a particle at the same time, or in the more extreme form, that a particle doesn't have a well-defined position and momentum at the same time. Um, and on the one hand, it's like, okay, this is great for people that want to have free will. We no longer have determinism. We can actually have, our we can have immaterial action affecting the physical world. But the drawback that being that it enters the scientific as just random. It's like, okay, well, it becomes a causal, which is very
Hmm.
different from having a non-physical cause. The again, the as he says, the physicist or the pure spirit has meaning for his physicist. But we also have this absurdity to say, okay, something is not isn't somewhere and going in some direction at the same time. It's either one or the other, which is an absurdity. Again, because a
Hmm.
pure spirit, an angel, could see the thing in its essential purity and know exactly what it's doing and where it is and how it's behaving. The fact that we are in some way restricted from seeing this is convenient for killing off determinism as a field. But if we try and make it the actual reality, we end up saying confusing things. We end up saying things that don't make sense.
Yes, it's
We give
important.
up on the existence itself. Well, it must be what it is, even if we can't know what it
Mhm.
is.
It's important to note, or to at least remind the audience if they don't know that. As far to my knowledge, correct me if I'm wrong, the Heisenberg indeterminacy principle only applies because we are material beings. The idea in the principle is not in itself. If someone could observe a thing without material means, what Mahayton calls empiriological means or concepts, you could observe it, which is the pure spirit. So it isn't a theory which says no one could ever observe it unless by no one they meant, material ones, material beings. Oh, well, hello everyone. Well, we're close to finishing, so now that I'm alone, I'm going to read some more. And if he doesn't join me soon, then I will end the stream. If he does join me, then I'll just recap him when I've read. In spite of the validity of their distinctions, we may hardly expect that the social behavior of the scientific and philosophical intellect will be more sensitive to them in the future than in the past. The new physics will influence the common intellect in the same irrational fashion as classical physics did. Through some sort of associative influence or sub-intellectual introduction, it will probably give birth in its turn to an inchoate philosophy, a new scientific tableau of the cosmos, which will save us from the former errors only at the price of illusions of another type. Doubtless, public opinions will be stirred up by a prejudice in favor of contingency and liberty, only by casting doubt on the substantiality of matter and the principle of causality. So, thus ends my notes for the section Dangerous Liaisons, which again, is a somewhat comic name to put on a book on epistemology and not a pulp novel of some sort. But on to the next section, which I believe is the penultimate. Let me see. Yeah, this section would be ontology and empiriology in the study of the living organism. Well, actually, instead of moving to a next session, I will stop here because I don't want to go to a new section without Ein present, and apparently he had to unfortunately leave us. So I will leave it here, and I will have to see you all next time. Oh, Ein. Or not, or Ein, are you there? Alas. Alas, I remain abandoned here, staring at a computer screen of my useless notes now that I have no partner, or that he is oddly silent. Wow, you can really feel that awkward silence and that dead air, can't you?
The freaking cat. Can you hear me now?
Yes, I can. What occurred there?
The cat decided to jump into my lap and somehow dislodged my mic, and then it didn't want to reconnect. It's my most sincere apologies.
No problem. I read one note while you were away just to fill some dead air.
I appreciate it.
In spite of the validity of their distinctions, so this is directly continuing after what we've read about the pure spirit, we may hardly expect that the social behavior of the scientific and philosophical intellect will be more sensitive to them in the future than in the past. The new physics will influence the common intellect in the same irrational fashion as classical physics did. Through some sort of associative influence or sub-intellectual induction, it will probably give birth in its turn to an inchoate philosophy, a new scientific tableau of the cosmos, which will save us from the former errors only at the price of illusions of another type. Doubtless public opinion will be stirred up by a prejudice in favor of contingency and liberty only by casting doubt in the substantiality of matter and the principle of causality. So I have to say, you got that dead on.
This is terrifyingly prescient.
Yeah,
Again,
that one's good.
He's writing in the 30s, and like the philosophy of nature that's going to rise from the new science is going to be prejudiced in favor of contingency and liberty by casting doubt on substantiated matter and principle of causality. That's exactly correct.
Yes.
It is eerie how prescient it is in my mind.
And it's almost I guess the closest he gets to sneering, almost by sub-intellectual induction will give birth to an inchoate philosophy, a new quote-unquote scientific tableau of the cosmos. And then public opinion will doubtlessly be stirred up by a prejudice in favor of contingency and liberty, which also says he really understands the public. But I suppose he is a Frenchman, so he understands his people too. They really do like contingency and liberty. Now, I have to give a warning. I have noticed no notes on these last few pages because they deal with biology, and I think I got bored.
So I'm looking over these, and we should try. So we have this last section on ontology and empiriology in the study of living organisms. We should try it. We've got about 10 pages left in the chapter. It's just this section. I think one more.
It's actually, I think, 3 more. So it's more divided than we think.
Okay.
So the two following sections are biology, which again, I've read it. I didn't take notes, so I don't know what's important and what's not. But the 2 sections are ontology and empiriology in the study of living organisms, which I'm not sure he's going to say anything radically different than what we've heard. He's only going to give biological examples.
As I recall, and I'm trying to find. I need to do a better job of highlighting. I need to get on Bulge's level. He unfortunately, while he was incredibly prescient with what the mythologizing of physics was going to do, he has this optimism about what's happening in biology in the 30s.
Yes,
And
that's the second section called the anti-mechanist reaction in biology, which is the very optimistic part of this chapter.
yeah, and he sees biologists in the day realizing, rightly, that okay, we can't have this mechanistic or deterministic, that there is something, a living creature is different than an inanimate object. Which the physicists of the 30s would probably tell you the opposite. There's atoms, they're interacting, they're obeying quantum mechanics, they're obeying relativity. We can, that's all life is just a certain collection of matter. And the biologists of the day are realizing, okay, that's clearly not right. There is something else. There is some living, there is some spark, there is some animus, there is a soul that is doing something. And Maritain expresses a lot of optimism that the biologists are going to try and, because they can't be as mathematized to the same degree the physicists can, are going to find their way out of this. And regrettably, he was dead wrong, and biology has become more and more mechanistic and more. I mean, molecular biology has replaced biology in the vast majority of scientific cases because it can be mathematicalized so effectively, and because it can be reduced to physics so efficiently. So while he was prescient in physics, he was way too optimistic about biology moving in any kind of true philosophy of nature direction. It has just become more, I think he uses the term empirioschematic, since it can't be empiriometric in the same way, because we don't have the same degrees of measurements in biology that we do in physics. But we start making, if anyone's ever taken an organic chemistry class, we have here's all the different molecules you can have and all the different reaction pathways they can follow. And we have all our pictures that we use to describe things. Since we can't have equations as effectively, but we schematize, that's probably not a word. We make schematics of the field instead of looking at what actually is. So I'm sure it'd be much to Maritain's regret is, and you see this in all aspects of biology, is biological investigation has been replaced by statistical measures. You see this in medicine all the time. Is okay, what's the percentage of effect that you see for this thing? What's the number, what percentage of people respond well to this? What number of the rabbits die versus live, or what? And it's reducing it to number, because that is something that we can work with very effectively, because physics works well with numbers and math works well. And again, eliminating the real and replacing it with statistical quantities has become the direction of biology. Is very much a statistical science instead of a philosophy of nature.
Yes, that summarizes essentially the two, in my mind, at least the two biological sections. And the last part is only 2.5 pages, is concerning the true and the false philosophy of the progress of the sciences in modern times. Now, I don't have notes in it, but I can sort of read certain sections. Or do you have a quick summary in your head?
Go ahead and grab something.
All right, so we believe that a particularly important truth emerges from the critical analysis of the empyreology and the ontology of the sensible, to which this chapter has been devoted, to wit, that the ever clearer differentiation between knowledge of the ontological type and knowledge of the physical mathematical type is not a simple contingent fact due to particular historical circumstances, but corresponds to a necessary law of the growth of speculative thought. It constitutes one of the most authentic advances in the order of the morphology of knowledge that thought has accomplished in the course of modern times, and of which reflexive and critical philosophy has become aware. We have noted that although the ancients clearly understood the method of the scientia mediae, which would be the middle sciences, which would be the physical mathematical, in certain privileged fields, nevertheless, they tended in fact to submit the whole knowledge of nature to the law of ontological or philosophical knowledge. So they had very little idea of the sensible as just considering the sensible. There is an inverse and symmetrical fault, more serious since it stems not from a de facto lack, but from a de jure error, which consists in admitting as legitimate knowledge, at least in the field of the knowledge of nature, only empirological knowledge dressed up under some other name. This has been the positivists' error. They have made this knowledge coextensive with the universe of thought. So that's all that you can think about, is that sort of scientific idea. Or ideas, I should say. In a quite different fashion, that error is repeated by certain philosophers, this time in the name of metaphysics. Of the scientific knowledge of nature, they retain only empiriometric explanation, and hold for naught the sciences of life. They wish to find a mathematical and physical mathematical knowledge of a unique type of all rational activity, when it is not purely reflexive, truly worthy of the name. And now, point 39, it's important to read his reaction to that. The attitude of these philosophers must be designated as retrograde, and to tell the truth, pre-Copernican, which is an interesting way of putting it. The arbitrary precept of a metaphysics which is constituted by a total and sweet renunciation of being and object obliges them to return to the positions of a most naive epistemological monism, proclaimed this time for the benefit of a type of knowledge which is farthest removed from any grasping of the real in itself. This false philosophy of scientific progress is thus prevented from discerning the profound sense of the Copernican revolution. It fails to understand the admirable organic diversity in the play of the intellect, which has been manifested by 4 centuries of scientific development, both within science itself and in the distinction of science and philosophy. All that is left of reason in the philosophy is reduced to the mathematical use, and to what we have here called the empiriometric use of the intellect. Here we have, if we may dare so to speak, a rationalism, that dirty word, which he's railed against in other books and in the beginning of this one, retired from business that tries to live like a gentleman of means, but can only maintain itself by drawing on the capital of ancient reason. But we wish to make clear that the principles of a realistic noetic, as expounded in the present work, provide a place within the system of knowledge for the methods and claims proper to the reason of this nominalist rationalism, granting their validity in certain defined limits, but noting at the same time that they cannot be the whole of thought. The capacity, now the final paragraph of this chapter, the capacity of a doctrine to integrate whatever is positive in systems which invoke different principles might perhaps be taken as an indication of its truth. In any case, it seems that a true philosophy of the progress of the physical and mathematical sciences in the course of modern times, precisely because it is its duty to set forth by critical reflection the spiritual values with which that progress is pregnant, must recognize in it the sign, not of a restriction and impoverishment, but of an improvement and growth within the organic structure and differentiation of thought. It must therefore, on the one hand, reveal the essential compatibility of this mathematical and empiriometrical progress with the knowledge of the ontological type which is proper to philosophy. On the other hand, it must respect the nature of the experimental sciences, which of themselves escape from complete mathematization, and it must render justice to their working methods, which will extend to ever larger sections of a scientific domain the more they assert their autonomy. In effect, it would be completely arbitrary to refuse to biology and other sciences of the same epistemological type the rank of authentic knowledge. This type of knowledge merits the attention of a philosopher and is playing an ever more important role, perhaps one day preponderant role, in the progress of speculative thought, which is a very optimistic ending to the chapter, and perhaps he will be right in 200 years.
One may hope.
One may hope.
It's an important thing to draw on here, and I think he makes a good point, because we had a lot of mean things to say, I think, and he did as well in this chapter about the new physics and the workings of science. It's very clear in his writing and in his mind, and I think it's very true, that by sort of unbinding itself from philosophy, the empiriometric sciences were able to explode. Like a big part of enlightenment, the growth of science a couple hundred years ago happened because it could because of this abstraction, because it would leave behind philosophy. It didn't, like the ancients wanted to do. They wanted to make everything an ontological knowledge. And one of the great benefits of the modern sciences, and by modern I mean Newton and forward, 300, 400 years of science, was that it wasn't trying to do ontology anymore. Is because if you try and do philosophy and be very careful and understand causes, you work well but very slowly. And this new method of this empiriometric method of doing science allowed for a very the rapid rise in I want to say understanding, but understanding is the wrong word because it isn't an understanding, but in the empiricism, in our ability to model and describe effectively, which has been extremely valuable. Untethering itself from philosophy allowed science to explode. But at some point, you need the philosophy needs to come back in there and reassert itself, and it can never escape completely from ontology. And as he says very clearly, there's a role for them to be. Let me get the exact thing. Yeah, so talking about the right philosophy, it must therefore, on one hand, and you just read this, reveal the essential compatibility of this mathematical and empirical progress with the knowledge of the ontological type, which is proper to philosophy. So there is great good to be had in the modern sciences, but it was in being untethered from philosophy that they were able to do that. But we have to realize that they've been untethered from philosophy, and the philosophy needs to come back needs to reassert itself.
As he says, they're not philosophy of nature and the experimental sciences are not complete knowledges in themselves.
Yes,
they're incomplete and they need each other. And it is only in this domain, which that there is such a duality to the order of knowledge, because as he says, mathematics is only formal, metaphysics is only spirit.
Mm-hmm. So with that, we end chapter 4 and really reach the end of most of my previous knowledge of Maritain. So chapter 5 is on metaphysical knowledge, and I'm excited to get into these things. I wanted to read this book for the discussion of the physical sciences and the philosophy of nature. That's what I wanted. I wanted to get his words on it because I think it's been very interesting to me and it's informed a lot of my thought. I am very excited to see where he goes from here and because again, I think chapter 5 is the last of the first major section, the first part, the degrees of rational knowledge.
Oh yes, which I'm excited for it to end because I think there's going to be a lot of more beautiful purple prose after that, which at this point might be more relaxing.
Yes,
than to read and to have digressions into real space.
So we have metaphysical knowledge is chapter 5, and that will conclude part 1, which is on it's the degrees of rational knowledge, and then we'll move on to supra-rational knowledge. So he'll start getting into mystical experience and Augustinian wisdom and Saint John of the Cross and Christian mysticism, and like you said, I think it's going to get less rigorous and a lot more beautiful because he is certainly capable of both. So I'm excited for the transition.
Yeah, so am I. I'm actually going to see how long this chapter is. Oh, it's oh yeah, okay. It's way shorter than the other one. By way shorter, I mean it's like 45 pages instead of 70. But it is quite much shorter. So less to go. I'm actually surprised we covered 70 Maritain pages in only 2 recordings.
We might get to chapter 5 in just one recording, and we might try and go ahead and do it in September, dear viewers. I think optimistically, I'd say we get it done and we do it before the end of September, but it might be October. We'll see.
We might do half of it in September.
That's not a bad idea. Maybe we'll try and get 20 pages in and see how it goes. Well, let's see how it feels to read. If it's it might be light and easy by Maritain standards.
Yeah, it is only 45 pages. It is only 45 Maritain pages, I suppose, instead of 70. Or it might be a chapter where, he repeats himself a lot, like he did in the latter sections of this chapter.
I will flipping through the pages a little bit. So one thing in chapter 4 that we didn't have, and I don't know if I missed it or not, was those beautiful Maritain diagrams.
Yes, we did not.
Which elucidate nothing and require a full text explanation to make sense of them. Chapter 5, I'm already seeing we have some diagrams again.
Oh, I'm excited for that. Let me see. Let me scroll. Oh my, I have seen them now. Oh my. Okay. Oh, we're back with the transobjective and stuff. Oh,
transobjective, intelligible, the paranoetic intellection phenomenon.
Oh my god! Yeah, I'm gonna have to share my screen later for that one. Okay, I see how it is, Maritain.
It comes to this.
It comes to this. All right. Yeah, I'm excited for that to be hit by that train coming in my direction soon. Page 7 of the chapter. Very excited for that.
All right, so Bulge, we'll figure out offline as we're reading when we want to try and do the next one. But
yes,
any closing words, any closing thoughts on the chapter you want to share?
I'm sure I will. as I think Mariton would wish me to do, I am going to reiterate that one should not build a metaphysics upon the theoretical conclusions of modern physics. And let that be, if you take one thing away from this chapter, by God, take this. Because Mariton really wanted to get that point across. You will make him incredibly sad if you do not remember this. Please, just take this.
All right. I think that's a good point to leave it on. We will see you next time.